Welcome to Future Perfect Tech, a webinar and podcast series by Harbor Research. Each month, we'll be having discussions with the leading experts in smart systems and the Internet of Things on innovations in markets, technologies, and ecosystems that are working together to build a better future.
I do believe in
the strange way I'm optimistic because I'm sure we're going to run into more big societal roadblocks.
When will we see mass adoption of edge technology
And is there a way to monetize that? Welcome to Future Perfect Tech. Today, we feature a conversation between Doug Standley and Glenn Almendinger about edge technology. Doug and Glenn cover some burning questions such as what killer apps will we see at the edge, and when will we finally see edge realize its full potential? Doug is a recognized leader in the design of disruptive technologies and applications. He is the founder and CEO of niolabs, who holds multiple patents in this space, and where he is pioneering edge-to-cloud distributed computing. Prior to niolabs, Doug was at Deloitte Consulting for 10 years as a principal, fellow, tech evangelist, and strategy leader. Glenn is the founder and president of Harbor Research, a growth strategy consulting and venture development firm that serves industry leaders to discover, design, and develop smart systems and IoT growth opportunities. Now, with that said, let's jump right in. But let's start off with a kind of an easy intro, which is essentially, what is edge computing and why should we care about it?
Yeah, well, I think maybe as a level set, I think as I think about edge computing, perhaps one of my biggest concern is that edge computing, like many other topics du jour in tech, will be categorized by few, but it will have many meanings. And so I think when we talk about edge computing, it's important to get granular. There are many different edges, and edge computing has been around for a long time. When I think about edge computing, it is allowing the processing, the computation, to be as close to the production as is required, as close as the application requires it. So it's not like every sensor needs a computer parked right against it. It depends on the application, and I'm sure we'll expand on that. Glenn, what are your thoughts?
Frankly, I mean, this is to me always been a part of the distributed system story, and because IT grew up in a batched environment, from an architectural standpoint, this is this hot new thing that kind of gets us beyond, essentially all this client-server legacy stuff that we're still breathing the last bits of oxygen on. But in many respects, it's part of a larger distributed systems story that includes things that have to do with, local or context-sensitive computation, but also have to do with data and the ability to essentially feed that data into that context and allow for things to occur wherever they need to occur. Why does it matter? Largely just because there's a huge amount of data that's getting increasingly spewed by the billions, and often people think eventually trillions of devices that will produce data. And you can't haul all that data back to a cloud architecture to compute and do things in very short microsecond, millisecond kinds of activities. So whether you think about autonomous driving, you think about augmented reality, you think about predictive maintenance on machines in factories or elsewhere, all of these promised applications and opportunities are largely predicated on the need for a fair amount of compute-intensive capabilities at that local point. And so I forget the fact, but some insane amount, like 88% or 90% of all data that's produced by anything becomes useless in its utility or applied value seconds after it's created. And so if you can't process it local within these time windows that matter to whatever kinds of decisions or events or functions are required, it doesn't work.
Yeah, and I would just add that I think that along that line, we've reached the point where there are applications that absolutely demand distributed edge computing. And so everything in the cloud, everything across the network,
Sure.
Full bandwidth, full data transfer, applications that frankly are just choking on that, whether it be from gaming or virtual reality, other things, right? But there's also, a really important factor. Why should we care? I think we've now reached the point where privacy matters. privacy and what we like to call user configurable privacy, and not just the movement of data, but the contextualization of data, and including establishing privacy rights and filters, obfuscation of data. We're exiting the period where trust the network providers, trust the cloud providers. Frankly, that business model has fallen completely on its ass with, of course, the outrage around Facebook and other. So we're exiting the day of trust us, we'll be good stewards of your data. And we now are going to see the regulatory pressure, not just out of the UK, but unilaterally, we're going to see that data sovereignty and federation of data and the control of data and the data rights is going to be moving back to the user, and whether it be the consumer or the enterprise. And so, and you can't do that if that data in flight moves across the network and is stored by someone else. It just doesn't work. So those rights have to move as close to the user's content creation as they can get vis-a-vis edge.
And be as flexibly deployed in that context setting.
Correct.
The availability of data, the ability to easily, readily, whatever, fuse data, the ability to combine elements in ways that the world isn't really organized to do that very well today in a, I'll just say, easy, fluid, open, and responsive way. So in many respects, the data dimension of this becomes, I think, the bugaboo, the big inhibitor of a lot of edges, distributed computing's value. But also, to your point, the fact that I need to be able, it's like I've been listening about personalization for 20 years.
Right.
and I still can't get my, my doorbell to recognize me and process my identity on the front door stoop.
Yeah, well, it can.
Yeah.
But the ecosystem, and we got to call like it is. The big ecosystem players, the people that own the pipes and the people that own the data centers, haven't been willing to transfer that right to you.
Right.
And I think that the new hype around edge computing, what we're hopeful of, is that the definition of edges will expand beyond just the network edge, right? It will expand into the computational edge.
Well, I think that's a great point, Doug, because, in many respects, it's great. If you did get 10 people in the room and asked them what the hell they mean by edge, you'd get 15 definitions.
Yeah,
but
exactly.
Most of them would find their genealogy back to the network edge, not app, not.
Well, why don't we use that at this point to maybe go shift tack a little bit and talk about some of the killer applications that you're seeing in the marketplace right now. Doug, do we want to start with you on that one? What is your top killer application? Well,
my top killer is maybe going to come a bit as a surprise to you, but I'm gonna go back to this user configurable privacy. I see opportunities in children's play. I think they're incredibly significant because no responsible parent will trust a telco ISV alternative or a cloud provider. Trust us, we'll secure your child's privacy. However, I also think those same parents would greatly embrace the notion of their 6 or 7 or 10-year-old child playing with a child in China in real time. So I think that the need to obfuscate in-flight, let's just stay on identity, is going to be the killer app for edge computing. So we're talking about having that edge secure network appliance that is configurable by the parent, where the parent releases permissions around privacy. The parent may be fine to know that the child's in Colorado or refine it to Boulder, Colorado, but they're not fine releasing their street address,
right,
which is in fact accessible to everybody that knows how to do reverse lookup through IP, right? So we do it in flight, right? Now, the obvious one for us is we've got to figure out a way to feed the planet responsibly without destroying natural resources and poisoning the soils. So edge computing, which we've shown is available, is a killer application for agriculture, precision agriculture, So I think that's where edge computing is going to come in. And I do think the lag on some of these big societal digital requirements like agriculture, I think edge computing is going to be incredibly important of that, because the ability to keep in balance or perspective user privacy, right? So, and latency issues and all the things that drive machine to machine to drive that need for how do you automate a farm.
Great. So, Glenn, perhaps your thoughts then on killer applications or the killer application in the edge.
Well, okay. So one is, if you just think about certain kinds of computation and data challenges, autonomous vehicles will need will need a lot of local edge, whatever we'd like to think about calling this in the future, processing, right? So, if automated guided vehicles are moving through warehouses or factories, you see robots picking Amazon goods for delivery and that kind of thing. Those are all classic cases of where there's a dependency on this kind of compute capability just to be able to process things fast enough that these things actually work. Think about the person who gets hit by the car in the middle of a city, and we want to inform the hospital. We want local processing to be occurring in the ambulance that will take that person to the hospital, and we want to be able to leverage traffic systems to understand what's the fastest route to the hospital, and all of that kind of combination of data values and network and data values come together, and obviously a complex set of moving parts to coordinate, but a high impact value, right? And so whether you think about emergency responses to things, and that could even be, back to Doug's point, around resource usage and utilization. Not enough water on the planet, ability to go optimize the supply chain to actually get food to people in places where it's needed. I mean, you can kind of go down the list. But I think the punchline is edge applies to almost everything. Almost anything in a local context can use more compute power to do things that allow us to do many things, if these issues like identity are really managed and governance and policy setting in the sense of individuals in the context of their privacy actually get put into play. So I strongly agree with Doug that privacy is an identity of these huge lightning rods in this kind of story, because I can't keep feeding all of my identity to everything on the planet and hope that at the end of the day, my life remains something that I can control. Doug, the other huge value, and Owen, you could relate to this, just take the road weather example. So you've got the ability to put sensors on vehicles now, and so whether I'm impacting the cost of fuel in the supply chain and how much that costs, and I'm saving resource, I'm just saving money by routing things in a more efficient way. I'm really combining real-time state-based data on what's going on the physical road. I want to be able to eventually combine that with today's forecast, and eventually be able to combine the real-time road data with today's forecast with weather models, things that understand things over much greater periods of time. And so, it doesn't matter whether I build the model in the cloud or off in some crazy lab someplace in a contained and controlled environment. I'm combining these models and these states with things that are occurring largely in real time. So whether it's spatial, temporal, whatever context I'm in, it's the ability to allow those different contexts of data to be able to come back and help make decisions or help enliven experience or save people or save resources or otherwise. I think they're all compelling cases.
Well, let's talk about a killer app that gets close to home to 100% all of us. One thing we all know is we all know how we do laundry. There are over 2 billion homes in the world that do laundry. They have laundry rooms. And we have an edge application of Neo with a consumer products company that is attempting to gain insight on the consumer and how they use the laundry room. So we learned recently that COVID, that during the first 2 months of the shutdown, this consumer products company actually front ran what the implications of stay at home that was in no planning algorithm, no planning forecast imaginable, because there had never been, frankly, a global pandemic, at least in 100-something years. So because we had an edge processor in about 1,000 laundry rooms, which is statistically relevant, random, we're able to understand the implications of what stay-at-home would mean to consumption of laundry products. So this company were able to adjust these forecasts, change their manufacturing orders, and we never ran out of that product in the grocery stores. Now, obviously, that was not toilet paper. Okay. So the toilet paper companies did not do that. But we also learned that because we were edge processing and understanding that consumer with pretty good resolution, that we picked up a packaging problem. A complementary product to do laundry had the wrong size package. So they weren't replenishing unless they replenished the laundry soap. So those two items in the first 2 months of COVID realized $145 million worth of benefits. $145 million.
Right.
Off of 1,000 homes. That could not have been done without edge processing, because we were able to bidirectionally change that research in flight, modify it, refine it, the context that we were looking for. We never asked the consumers to change their behavior one bit. So now we're starting to think about the laundry room and the implication of the laundry room. The laundry room is the second largest user of water and power in the home. So why do we have dumb laundry rooms? But also laundry and CPG companies are being pressed down by the distribution model. And so why can't laundry products become direct to consumer? Of course they can. But to do that, you don't want to guess. You want to know what the consumer is using. So I'm going to give you a little bit of a forecast. You can expect that in the future, we're going to be involved in an intelligent laundry room. And that is going to be enabled by processing consumer behavior and consumer usage locally at the edge in a laundry room. The thing that I'm excited about is I want to control my own experience. I think it's the user experience that's going to change. It's self-directed advertising. It's all of the stuff that we can do on the edge with in-flight content and contextualizing that in microseconds, right? And so that, from a user standpoint, is just incredibly exciting to me. I hate to say this, but COVID may be the great unlocking agent, the wild card, frankly, for cooperation, for automation, and collaboration, and frankly, explosion of applications.
Doug, Glenn, thanks so much for your time today. To our listeners, this is just a segment of a really rich 2-hour conversation. So stay tuned for part 2, coming to your favorite streaming service soon.
Harbor Research is a growth strategy consulting and venture development firm with over 30 years of experience working with leading manufacturers, service providers, and technology developers to discover, design, and develop smart systems and Internet of Things growth opportunities. Visit harborresearch.com to learn more or follow us wherever you get your podcasts.